In today's chapter 26.2 Resistors in Series and Parallel, we will be going over the definitions, the equations, and examples dealing with series and parallel circuits.
Alright, my name is Kiani Shepard and I'm going to do the definitions for 26.2. The first definition is of resistor. A resistor is a device that limits the flow of electric current. If you're going to draw a circuit, this is the symbol that you use for a resistor. The second definition is a series. In a series circuit, there's only one path that the electric current can flow. It goes from the battery to one resistor to the next resistor to the next resistor. In a series circuit, the current is constant and the voltage changes throughout. The last one is a parallel circuit. In a parallel circuit, there is more than one path for the current to flow. It goes from the battery, and here it has a choice to either go to this resistor or to continue on to the next one. And when it comes to here, it can either go to this resistor or continue on to the next one. In a parallel circuit, voltage is constant here, and here, and here, but current changes as you go through.
In chapter 26.2, we'll be solving questions that have to do with series and parallel. For us to understand and get to a final answer for these type of questions, we need to know the formula. So you see here we have Ohm's law, which is V equals IR, and then you have V1 equals IR1, V2 equals IR2, and V3 equals IR3. V stands for voltage, I stands for current, and R stands for resistance. And then we come here, and we separate these types of formulas, for one for series and one for parallel. As you see for series, we have V equals V1 plus V2 plus V3. And then we have H equals IR1 plus IR2 plus IR3. But for parallel, we have I equals I1 plus I2 plus I3. And then continuing from parallel, we have I1, which equals V over R1. I2, which equals V over R2. Then we have I3, which is V over R3. And then we have the equivalent resistance. So we have one part for series and one part for parallel. For series, it is V equals IR1 plus IR2 plus IR3. Since we have i's here, we can factor it out. When we factor it out, we can cancel out the i's and we're left with this part here, which is R equivalent resistance equals R1 plus R2 plus R3. And for parallel, we have I equals V over resistance equivalence. So we have V over resistance equivalence, V over R1 plus V over R2 plus V over R3. We can factor out the V's, and then it cancels out, and we're left with this final right here, which is 1 over resistance. Then we get 1 over R equivalence, which equals 1 over R1 plus 1 over R2 plus 1 over R3. Now Jarvis will use these equations to solve these type of problems that have to deal with series and parallel.
What you just learned from Kamal Hussein and showing you how to use the formulas, we're going to put the formulas into effect to solve problems and find the equivalent resistance, the total current from the power supply, and the current through each resistor. In a series current, we have 125 voltage, 20 ohms, 30 ohms, and 50 ohms throughout the whole current. To find the total resistance, you do resistor 1 plus resistor 2 plus resistor 3, which equal to 20 ohms plus 30 ohms plus 50 ohms. The total resistance equal 100 ohms. To find the current through the power supply, you do Ohm's law, which is current equal to voltage divided by resistance total. Current equal to 125 voltage divided by the 100 ohms that we saw from the example A. So your current will equal to 1.25 amps. After you saw that the current through each resistor is consistently throughout the whole series, since it's one series, so it's consistent throughout each problem. So current equal to I1 current equal to current 2 equal current 3, so your current resistance will be 1.25 amps. Now, in a parallel current, you have 125 voltage with 20 ohms in the first resistor, 100 ohms in the second resistor, and 50 ohms in the third resistor. Now to find the equivalent resistance, you do 1 over each resistor plus this next resistor. So it'll be 1 over current resistor equal to 1 over 20 ohms plus 1 over 100 ohms plus 1 over 50 ohms. The total resistance, now you need to find a common denominator, which is 100. So that's why we have 5 over 100, 1 over 100, and 2 over 100. So the total resistance will be 8 over 100 ohms. Now to find the total resistance, you do reciprocal. So it'll be 100 ohms divided by 8, which gets your current resistor, which will be 12.5 ohms. Now, to find the total current from the power supply, you do current equal to voltage divided by total resistance, which is 125 voltage divided by 12.5 ohms, which your current will equal to 10 amps. Now, the difference from a parallel and a series is when you have the current through each resistors. To find each current through each resistor, because this is resistor 1, resistor 2, and resistor 3. So you'll take the 125 voltage divided by each ohms through each resistor. So to get the total current, you do 125 divided by 20 ohms, and you get, for resistor 1, current is 6.25 amps. For current 2 in resistor 2, you'll get 1.25 amps. For resistor 3 current, you'll get 2.5 amps. And that's what we have for parallel and series.
My name is Arian Johnson, and I will be explaining the combination of series and parallel. Consider the circuit shown in the figure to find the total resistance. We have 28 ohms, 2 ohms, 25 voltage, 16 ohms, 14 ohms, and 48 ohms. We have 2 parallel ohms in this one circuit. Okay, we're going to let RA, RB, RC, RD, and RE. RA is going to equal the 28 ohms, RB the 2 ohms, RC the 48, RD 14, and RE 16 ohms. Here we have RA and RB that are parallel. We have 1 over the total RAB equal 1 over RA plus 1 over RB. Down here we have the same thing except with the reciprocal, which is going to equal 1 over 28 ohms plus 1 over 2 ohms. With reciprocal is going to give us 1.8667 ohms. On this side we have RD and RE that are parallel. We have RDE is equal to 1 over RD plus 1 over RE reciprocal equals 1 over 14 ohms plus 1 over 16 ohms reciprocal, which is going to give us 7.4667 ohms. Then we have these resistors that are in the series. We have the total resistance equal RAB plus RC plus RDE, which is going to equal to 1.86667 ohms plus 48 ohms plus 7.4667 ohms, which is going to equal 57.3333 ohms. Thank you.
Here's a short review of today's session. In a series circuit, the total resistance of a resistor in a series is equal to the sum of their individual resistance. Using Ohm's law to find current is voltage divided by resistance total. The current is constant throughout a series circuit. In a parallel circuit, the voltage is constant throughout the circuit. To find the total resistance of our resistor, add the reciprocal of the resistance of each resistor and take the reciprocal of the sum. Using Ohm's law to find the total current, voltage times the reciprocal of the resistance total. To find the current for each resistor, you use Ohm's law in current equal voltage times the reciprocal of each resistor.